Thanks for joining us in our ELPRO technical series here. And today's session is going to be two parts. The first part will be on how to set up text messaging from the 645M-4, our cellular modem. The modem has 4 digital inputs across the bottom, and we're going to show you how to get a text message or email upon those inputs changing state. The second part of the webinar today is going to be on Modbus setup, how to set up the Modbus TCP to RTU converter in the 645M-4. Okay, so just a little bit about the 645 here. We call it the industrial Internet of Things device enabler. It has 4G cellular communications with 3G fallback. And what that means is that because cellular modems can be accessed via the internet, that means you can access this device from anywhere in the world that you have an internet connection. And as long as the cellular modem has cellular coverage with one of the carriers, we're going to show you how to get a discrete signal sent to your cell phone. And you could literally be located anywhere else in the world. As long as your cell phone has cellular coverage, you can get a text message or email sent from the device directly to your phone. So it's a very, very powerful device. It really is quite interesting. One of the things I found was in testing this all out, setting up text messages was actually pretty simple. It's not a complicated process. You don't have to be a rocket scientist to be able to figure this out. So what we're going to do is we're going to show how we can use the 4 DIO on the terminal block across the bottom of the cellular modem. We're going to use them as digital inputs. Now, when we say DIO, we mean that the IO point can be used as either an input or an output. Today, we're going to show use as inputs. Okay, now here's one pretty cool application that a customer recently set up, and it's flood monitoring of a road. And this is in Australia. They're subject to a lot of flooding in some areas of the country, very low-lying, very flat terrain. And sometimes they'll have flash floods too that occur in mountains some distance away, and the water eventually rushes down to a point where seemingly it's dry and the weather seems good, but flash flooding can suddenly cause river levels and creek levels to rise dramatically. So in this case, they're looking at this point here, and one of the issues is this is a pretty rural area, and drivers at nighttime, they just drive down the road, and next thing you know, if they don't see the water, they drive right into it. So they've actually got sirens that they have installed in this area that go off when the water level gets too high. So in this case, what they did is they have a float switch wired into a digital input on our 645M-7. That sends text messages to staff to let them know they're going to have a problem. They're going to that they've got an alarm condition here. They're probably going to have to dispatch crews the next day to clear the road and the debris away once the water levels recede. And what they also did was they hooked a video camera up to the cellular modem's Ethernet port. And what they can do is they can then log into the camera and get a visual indication of conditions here. And if you look at this one, this is quite recent. This is just a week or so ago. You can see that's 14:17, so 2 o'clock in the afternoon, and by 19:17, by 7 o'clock at night, the area was completely flooded. So these can happen very, very quickly. So it's a very significant concern in this part of the country here. But anyway, some very cool things you can do with these cellular modems here. Now for today, this is what we're going to talk about. This is what our network layout is going to look like. So over on the right-hand side, we're going to have our cellular modem, and for our inputs across the bottom, We're going to assume we're connecting a pump run switch. We're going to connect a pressure switch. We're going to connect an intrusion alarm switch and a float switch. So typical water, wastewater, pump station application. And the cellular modem will connect to the nearest tower. It will connect through the internet. It will then relay that signal out to the nearest tower to your cell phone and display the message either by email or text on your phone. So very powerful. You can get all kinds of alerts. Any type of switch can be wired into this cell modem. Now we're looking for just a dry contact, so just a voltage-free relay, and that could be triggered off of anything. That could be humidity, temperature, level. That could be chemical composition. There's all kinds of industrial switches for any type of application out there. Now, also, I just kind of threw this in, but this radio has multiple I/O points. We also have the Ethernet port on the top of the radio, so we could connect it directly to a PLC in this example as well, or this could be a video camera, or this could be any Ethernet-based piece of equipment that is being done simultaneously while the digital inputs across the bottom are being monitored. Okay, we're not going to talk about the Ethernet aspect of it today. We talked about that in some previous webinars, and we do have links available to some of these other webinars that we've done on accessing Ethernet equipment via the cellular modem. Okay, well, the first step in getting one of these cellular modems activated is you need a SIM card and a data plan from the cellular carrier. Okay, so there's two options really. You can either go into a Verizon store or AT&T store or whatnot and get the SIM from them. Just make sure that you tell them it's for a cellular modem. And the other aspect is ask them to see if SMS or text messaging is enabled on that SIM. A lot of times it is automatically, but something you will have to double check when you purchase the SIM. Now, rather than go to a carrier like Verizon or AT&T, where the technical support can be difficult to access and their primary market is focused on consumer phones, instead, I've had great luck with a company called M2M Wireless. They're down in California, and they sell SIM cards in all the major carriers. So Verizon, AT&T, T-Mobile up here in Canada, it's Rogers, Bell, and TELUS. But they can provide SIM cards literally for any country around the world. So the company is great. You pick them up. The tech support is there immediately. They know exactly what the applications are, and they're familiar with a lot of different types of cellular modems. They can help you get the modem connected to the carrier. So I've had tremendous luck in dealing with a small private company that exclusively deals in selling SIMs and data plans only for cellular modems, not for phones. So they know exactly what you have to set up and all the different options here. Now, you'll have the option of either a fixed or a dynamic IP address. For text messaging only or SMS use only, it doesn't really matter whether it's a fixed or dynamic IP. I prefer fixed IP because it's a little bit simpler, especially if you're using a SCADA program. It's just a little bit simpler. Then you have the option, you can either get a private or a public IP address on your SIM card. For text messaging, I would get a private IP address because private IP addresses are more secure. There wouldn't be a compelling case to get a public IP if you're just using the text messaging capability. Okay, so once you have once you've received your SIM card from the carrier, insert the SIM into the socket on the rear of the radio, power the device up, and then type in the IP address for the cellular modem in your browser, and up will pop in the setup page. So then what we have to do is we have to go to our setup wizard. We enter the parameters given by the carrier, including especially the APN. That's one piece of information you will need to have from the carrier. Now, I'm going over this fairly quickly because we do have other webinars that ran through this process in much greater detail. But once you've got the SIM in, you've gone through the setup wizard, you do a save and reboot the unit, wait a minute or so. Then what we're looking for is this up cellular status. The up cellular status now means that we have a connection to the carrier. Also on the outside of the cellular modem, there's a bunch of LEDs. Have a look at the cellular LED. It should be solid orange when it has a connection to the carrier. Okay. And then this is the IP address of this particular cellular modem, of the SIM card inside this cellular modem right here. Now, it's not important for the purposes of setting up for text messaging, but you may want to have that on hand in case you're using the modem for other purposes as well. Okay, so once we've got the cellular modem provisioned and connected to the carrier, then the next step is our SMS setup. So what we do, we click on services, then we click on SMS, and then we have to head over here to the DIO SMS tab. Then the next step is we need to enable the SMS outbound alarms. So this is for the cellular modem to generate the messages and send them to your phone. Then all we do is we just type in the text message that you want to receive when each digital input changes state. So in this case, I've got it really simple. I've just typed in digital input 0 has gone high, digital input 0 has gone low. But you know, if this were monitoring an intrusion alarm, you would probably want to say door open, door closed, that sort of thing. Or if it was a pressure switch, you could say something like pressure vessel high, pressure vessel low, that sort of thing. And you just type in whatever you'd like to receive on your phone in these parameters here. Once you've got this set up, you hit save and apply. And keep in mind, you have to save any changes that you make when you move from tab to tab to tab. Otherwise, if I make some changes here and I forget to click save or save and apply, when I move to the next tab, it's going to forget what I just entered in here. So we have to save changes before we move off this tab. Okay, then the next step is we need to click on the phone number tab. And here's where we're going to enable the services that we want and enter our phone number. So in this case, we're just enabling the digital input output change. And we don't necessarily need to enable the SMS alarm that allows you to get alarms on things like low radio signal strength. And there's a couple of other parameters that more or less diagnostics that the cell modem could send you. We're not going to bother with any of those today. We're just going to focus on getting a signal from the digital inputs across the bottom there. You might also notice we have SMS command. And what that allows you to do is to send a command from your phone to the cellular modem. And you could, for example, turn on a digital output, or there's a couple of other parameters that you could monitor. For today's purposes, we're just going to focus on the digital I/O across the bottom. So what we do, we enter in the phone number, and you enter in the phone number as it would be dialed. So for example, if it's a long distance call, we enter 1 in front of the phone number. If it is just a local call, then we just enter in the area code and the rest of the phone number there. We can have multiple phone numbers. If we want to add more phone numbers, we just click right here. We create a new group name, and that then appears up here. And then you have a duplicate set of all these parameters, and you just turn on whichever services you want for that phone number. So we can have a whole bunch of phones all receive the same text message upon triggering a digital input on the terminal block. So it's kind of cool. You can have a bunch of people all alerted to the same general alarm condition. Okay. Then we just have one last step, and this is changing these default values. The default value is that they're all low. So we change it to high. And the reason for that is then we can just use a dry contact, a voltage-free input to the digital inputs across the bottom of the radio. If we leave it in the factory default, which is they're all low, then that means if we take a jumper wire and we short that input to ground, it's already low, so it would not see any change. We would have to use a voltage source to trigger these inputs. But we don't want to do that. It's much simpler just to have a dry contact. Therefore, these 4 values here need to be set high. Then this follows the same logic as our 915U2, the 415U2, the 215, etc., whereby their digital inputs are just triggered by a jumper wire across the jumper wire from the digital input to ground. So we just need to make these changes, click Save and Apply, and then we are good to go. Okay, so the next thing is testing. So what we would do is we would take a jumper wire, and you can see across the bottom, we've got the 2 ground terminals there, and then DI1, DI2, DI3, and DI4 are located right there. Now the software starts at 0 and calls them DI0 to 3. We call them DI1 to 4, same thing, same thing. Okay. Now what you can do is just you insert your jumper wire between ground and any of the digital inputs, and then you should see in this SMS log, you should see these messages that show what text message was sent out. Okay, it'll also show you the phone number that it sent the message to, and you should receive that on your phone. Now, during my testing here, one of the things I do is I just insert the jumper wire for about 10 seconds, then I pull the jumper wire back out. What I noticed was that I was getting the text messages in the wrong order. And when I was speaking to a colleague about it, he advised me that this is the carrier's issue. Sometimes the carriers do not deliver text messages in the correct order or as expediently as they should. And he said there's nothing you can do about that. It just, sometimes you send a text message from your phone, your friend might not get it for a couple of minutes later, and that's just a carrier issue. There's nothing we can do about it, but the messages always do get delivered. So that's the important thing. And then the next thing is have a look at your phone and see if you got the message. So this is a little snapshot. You can see these messages are all popping up on my phone. And what I did was I created a new contact from the phone number that delivers the text message. Now, the phone number is tied to the SIM cards to the carrier. When you buy the SIM card, we'll tell you what that phone number is. Doesn't really matter. I just created a new contact, and you would use the location or the name of equipment that you're monitoring. And overall, it's a fairly simple setup, especially if you have a private IP. Private IP means that nobody can access your cellular modem unless they were able to get a VPN into the carrier, and even then the carrier restricts who can access your modem. So these become very, very secure. So really that's about it. The whole process, setting up the cell modem for text messaging, probably 20, 30 minutes. You got to fiddle around, get the SIM card in there, reboot the device, once or twice and that sort of thing. But it's not an overly complicated process. Okay, so that was setting up the device for sending a text message. The next is how to set it up for an email message to be sent. Now, one of the things you have to do is you have to enter in the email account that the message will be sent from. So this means that the cellular modem is now accessing your email account and sending it to whatever other email address you would like. So the first thing we have to do, we go to our services, we head to SMS, we go to DIO mail, and then we have to click enable. Then we have to enter the SMTP server of your email account. And this is what it is for Hotmail, for example. For Gmail, it's a little bit different. Then you have to find out what port number your outbound email service uses. Okay. Then we have a couple of other details that you have to enter. This is actually the email address. Obviously, we don't want to reveal anybody's email address in this webinar because it will be public. And the password is the password you use to log into your email account. Okay. Then we have to check these services to see whether your email account, whether it utilizes these or not. And we know what all the settings are for Gmail accounts. That's one of the things we use to just test it out. So that is fairly quick to set up. Then we have to scroll down. There's a few more parameters a little bit further down. Okay. So then you have two options for what the email message is going to look like. You can either go with the cellular modem's generic template, or you have another option of self-defined message title and message content. So with the system template, you're just going to get pretty basic messages, and you just type in whatever you want to receive here. But this is what I think most people would want to do. This would be the title, or when the DIO changes from low to high. So it could be something like intruder alarm notification if it were a door switch on a pump station or something like that. And then you would just enter in the text, door opened, and then door closed, and that sort of thing, and different titles for each of the digital inputs. Okay, once you've entered in all the information that you would like to receive by text, you have to scroll down a little bit further. This is now where we enter in the email addresses that you want to receive the messages from. So what you have to do is put a tick mark here to enable the email to be sent on a digital input change. And then you just enter in the email address of the destination. So this is who's going to receive the email message. Okay, now just like with text messaging, we can have multiple email addresses all receive the same message. All we do is we enter in a new group name that appears up here. We click add, and then it comes up with these two boxes right here. And you just type in the new email address in the box. Okay, so you just keep adding your email addresses until you're ready to go. Then we hit save and apply. Now all this information is applied to the radio. And now what we can do is we insert our jumper wire into the bottom of the, from say DI1 to ground. And then we check our email account to see if we receive something. Now, for troubleshooting purposes, this is a little bit more complicated to set up because you got to get the port number right, you got to get the SMTP server correct. So sometimes you might make a few mistakes. What you can do is you can go to the system log in the cellular modem to see a record of the email being sent. And it'll tell you if there's an error, it'll have some error message there, but you can see the record of the email being sent. So that is by clicking on status and then system log. Okay, now there's one other thing that we found when we're testing with Gmail, and that is you may have to go into the your Gmail settings and change this parameter. And basically what it is it's a security thing. Google restricts devices from accessing email accounts just for security purposes. They don't want just anybody getting into email accounts. So we found this setting. We had to enable it to allow less secure apps to access the Google account. Okay, so that's one little hiccup that we found that you may have to might have to do on your Google account. Okay, so now that we've shown you how to set up text messages and email messages, the second part of this webinar is how to set up Modbus TCP to RTU converter in the cellular modem. And what that allows us to do is we can connect our 115S serial expander modules to the RS-232 port on the bottom of the cellular modem. Now, we also make an Ethernet expansion module, the 115E-2. And of course, you can connect that directly to the Ethernet port on the cellular modem. So there really are two methods of doing so. But in this case, we wanted to highlight Modbus RTU because it uses serial ports, and there really are thousands of Modbus RTU devices out on the market. Okay, so this is showing what the setup would look like. You would have your laptop or your SCADA host at one location. It would be connected to the internet. Through the internet, it's going to go to the carrier's cellular network. Then it'll travel over the air from the nearest tower to the 645 cellular modem. Okay. Now, one thing to think about is SIM cards, public or private IP address. Now, we have another webinar where we discuss this in a fair bit greater detail, and there are some pros and cons to both types of setups there. A public IP address can be accessed by anyone on the internet. So if I know what the IP address is of the SIM card in your cellular modem, I can just go to something like network-tools.com or any other utility there, and I can ping it. I can ping the public IP address. Now, one of the advantages is that of a public IP is we can use a VPN service like OpenVPN. Now, it's fairly complicated to set up, but it does require that you use public IP addresses. And once you've got them, then it's generally a pretty secure connection. And we've got a webinar on how to set that up there. Another option is private IP addresses, and they are much more secure because nobody on the internet can access it. So it means, you know, all these bad people, these bad actors, and you know, criminals in countries like Russia or China or wherever, you know, they could be based in the US or Canada as well. You know, bad actors cannot access your equipment if you have a private IP address. So what you have to do is you have to VPN into the carrier's network. So there's two methods of doing so. One would be to get a VPN set up directly into Verizon's network or AT&T. I would suggest that's a bit of a lengthy, bit of an expensive process to do. Or another method is you can use the VPN service from a company like M2M Wireless. And they had me up and running in about less than an hour to get the whole thing set up and logged into my cellular modem. So it really, dealing with them was a very simple, very straightforward process. So I'm a little hesitant to recommend you contact any of the major carriers directly, since I don't think this is their core business. Their core business is consumer telephone products. So we do have to give some thought as to how we get in. We generally have to use a VPN if we're going from a laptop connected to the internet to a cellular modem. So you've got these two options here. Again, we got a webinar that talks about them in much greater detail. Okay, so to set up Modbus, it's actually pretty quick. What we do is once we have the modem provisioned, we're connected to the carrier, and our cellular status is up. Then we go to services over here, and then we click on Modbus. And then we just have to enable Modbus to RTU enable. And then we just need to set the serial port settings to match the device that you're connected to. Everything else, you can just leave as factory defaults. So that's it. All these parameters are already set. The only thing I really had to change was just the baud rate to match the baud rate on our the default baud rate on the ELPRO 115S device. So yeah, pretty simple. Now we can pull from a laptop all the way through the internet, through the carrier's network, through the cellular connection, through the 645M-4 into our 115S serial expansion module. So once I have these settings done, I just click Save and Apply, and presto, you're pretty much done. Now there is one extra thing we'll have to do is we will need to add a port forwarding rule, and we will need to open up this port to allow it through the cellular modem. So what we do is we go to the network page, we go to firewall, and then we click on traffic rules. Then what we do is we want to create a new rule. So Modbus uses port 502. We can leave it open to TCP and UDP, and then we just type in a name. And in this case, this is just general text. We just type in Modbus. Then we click on Add, and the next thing you know, you'll see Modbus is allowed, is one of your rules enabled up here. Okay, then we scroll down, click Save and Apply, and then we need to wire it up. Okay, the 645M-4, it functions as a DCE device, so we may have to wire it differently depending on the external device that we want to connect. Now, the 115S device, I believe it's also a DCE, so I believe we would need to wire it in that fashion. That's one point I didn't actually double check recently here. I can't remember quite exactly how I did wire it up, but we do need to double check it. If it is a DTE device, then we just wire it pins 2 to the transmit, 3 to the receive, and then pin 5 to ground. And that's all the pins that we would use. Okay, so then once we've got that wired up, then the next step is we need to establish our VPN. So in this case, this is showing my VPN setup into the carrier. This is assuming I'm using a private IP address, so I'm using M2M's VPN service. Then what we do is, in this case, I'm using Modscan, so that's a Modbus master device. And I just connect using a remote Modbus TCP server. This is the IP address of my SIM card that was provided by the carrier. So in this case, this is a private IP address here, but since I've got my VPN set up, I can now access this IP address, and I can even ping this IP address from my command prompt. We enter in the service port of 502, and that's our Modbus port. We hit OK, and the polling begins. So yeah, a couple of steps that you need to set up. But now we've got access to any Modbus slave device that we can hook up to the 645 serial port across the bottom. So yeah, kind of cool. Pretty interesting setup. It's amazing remote access, what that now enables. You can know what's going on anywhere in the world, literally. It really is quite incredible. So I just want to take a minute. I think I've covered just about everything to do with the main topics that I wanted to discuss. But I also wanted to talk about some of the applications where we've seen these cellular modems. Oil rigs, there's all kinds of parameters. They're monitoring flows, they're monitoring pump cycles, just everything. Tons of different parameters on oil rigs. That's often a fairly big industry for us. Fracking trucks. This is what these guys look like here. All kinds of parameters they want to be monitoring as well. These huge mining trucks. Can you imagine if a customer says something's overheating or it's not performing well or something isn't working properly? Well, the manufacturer can just stick a cellular modem on it and then log directly into the diagnostics on the mining machine right where it is, rather than having to fly a technician out to some remote mine site and then log into the device directly. So huge savings in mileage, time, and manpower. And here we go, the pump station. We have tons of wastewater customers that use these cellular modems for monitoring all kinds of different parameters. Power metering. You can hook these up to these power meters and monitor your power consumption, especially important with with electricity prices constantly going up, etc. HVAC units. These are huge rooftop units that they ship on the back of an 18-wheeler. And whatever the factory is in one part of the country, but commercial buildings are all over the world. So when these units arrive, if the customer says it's too hot, too cold, the fan's not working, or something like this, it's very easy and very efficient for them to diagnose this remotely using a cellular modem. So, and it just goes on and on. I mean, literally thousands and thousands of different applications. In fact, we've got a customer that have Gulf irrigation systems. And when they're overseas or in different parts of the country, they can log into the network over the air using our cellular modems and see what the network is doing, how conditions are performing. So just thousands of different applications for these devices here. So this is one where this company supplies fracking fluids to oil companies. And so they previously, they just had trucks that would drive from site to site and fill up the fracking tanks with fluids. And they had no idea whether these tanks were empty or full, whether they need a lot of fracking fluids or very little, etc. So they stuck a level sensor on these tanks, and they used our 915U2 meshing radio to transmit the data and use each site as a repeater to get it to a location where they had cellular coverage. And now they know exactly what the levels are in all these tanks, and they only dispatch the trucks to the tanks that are low. So huge savings in mileage, in fuel, in labor, in wear and tear on the truck, everything. So very, very, they were extremely happy with how this worked out for them. Okay. Here's another one doing some oil rig monitoring in Texas, and they had some areas that did not have cellular coverage, so they used our 945 Ethernet radios. And what they did was they took the data. They're monitoring a whole bunch of parameters via Ethernet on one rig, used another rig as a repeater site, got it back to the location where they had cellular coverage, jumpered the Ethernet port of the Ethernet modem into the Ethernet port of the cellular modem, and now they're accessing all of this equipment here via this one cellular modem. So yeah, again, just another application, hybrid application, where they're mixing 900 megahertz radios with cellular to allow for remote access. Okay, that's it for today. Hope you enjoyed it. And let's see if we have any questions here.